This is a demonstration of the domain of a function, and we'll probably get to range and increasing and decreasing in the next couple segments. So I have this set up so it shows a domain down here, and this will move it back and forth, which is kind of cool. And you'll notice that where this domain is right now, there is no graph above it. So this is not part of the domain of this function, this graph. But when we start getting the domain directly under the function, we start generating these points, and I called it A. So wherever that A is and wherever the green dotted line is, there is a domain for this function. And it stops when it gets to this point, and after that it disappears. So the domain of this function starts here and ends over here. Alright, so let me just turn on a little feature here. If I can do this. Oops. Alright. And start it over again. And go kind of slow, and it draws all these lines. So the domain is everywhere underneath this graph. From here to here. So to write the domain of this function, the domain started here, and this value was -3, and it ended way over here, and this value here is +5. So we write the domain as D:, because these were solid dots and not empty circles, we're going to use bracket. The lowest value that the domain achieves is -3, the highest value it achieves is +5. So that would be the domain of this line segment. Alright, here's the example for range. Got the same kind of thing going on. But in this case, and one thing I forgot to mention last time is domain is always going to move from left to right. So that arrow that I had pointing is there for a reason. Same thing for the range here. Notice it's always pointing up. So range always starts off with the negatives and then ends up with the positives. So smallest to largest. So as we move this one up, there is no range for the graph here because there is no graph to the left or the right. So the range doesn't start until it gets to here, 1. And it starts generating that point on the graph. Then as we move it further up, we still generate these A's. And it doesn't matter what side of the y-axis it's on as long as there's a point on the graph. And eventually it stops up here. And I couldn't get it precise, but it should be 3.666. It's 3 2/3. So the range here, let me do something first. Drag him back. So therefore the range is all the y values where it exists on the graph. So down here, again, it doesn't exist. So if I move it up, we start getting a range at 1. And then the range stops at 3 2/3 up there. So all these values on the y-axis become part of the range. And then after that it stops. Alright, so to write a range, we're talking about how low does the graph go, and in this case it was 1, up to how high does the graph go, in this case it was 3.66, repeating. Alright, so we would say range from, again, it's a solid dot, so it gets a brace. If it was an open circle, it would be a parentheses. So the range here is from 1 to, I'm going to be precise here, 3 2/3. I hate writing mixed numbers, but in this case, decimals aren't much better. Alright, so remember the domain of this thing was how far to the left? It was -3. How far to the right? It was +5. So far for that line graph, the domain and range are now fixed. Alright, here's a little bit more complex of a situation. Pretend that there's closed circles at each end of this graph. And we're also going to run this domain value through here to see what's happening. And instead of just dealing with x equals and y equals, I'm just going to look at the point as a coordinate itself. And just remember that the x coordinate is the domain and the y coordinate is the range. So again, over here to the left, there is no domain or range because it's not generating a point. And it doesn't start generating points until it gets to right here. So the domain of this is starting at -3. There's nothing to the left of it. As we move across here, the point's going up and down and doing whatever it's going to do, but there's still a domain value on the x-axis for this graph. In other words, there's a graph above or below the x-axis wherever B is, or that blue triangle. And you always move left to right. So then the domain stops here at 2, and nothing exists all the way to the right. All right, so let me turn a little feature on. And get an idea of where the domain is. The domain starts here. It exists for all of these values on the x-axis. And it stops over here at 2. So when we want to write this domain, the farthest to the left that it goes is -3. So we'll start off with domain, colon, bracket, because we're assuming that these are closed circles. And it starts at -3, and it ends way over here at 2. So the domain of this function would be from -3 to 2. There's nothing to the left of it, and there's nothing to the right of 2. All right, let's go back to that graph and get rid of my little drawing so far. Now, what's harder is the range. And the problem with range, especially with this, with this graph or this feature, is it's not a nice function. In other words, it wraps itself around for values of y. So if you look at y equals 3 here, there's actually 2 values of x that would satisfy it. And that causes a little problem. So we're going to have to just analyze this a little bit better. Let me turn this off. So when we're looking at range, we're looking at basically the y values. So here we're going to be looking at the second coordinate. So part of the range is 1.5 and all these other numbers. So what you're looking for is the highest number and the lowest number. And those generally happen at the highest point of the graph, and in this case, here's the lowest point of the graph. So the lowest this graph goes is -1.17. So that would be the base of the beginning of the domain. You always want to start with the bottom and work your way to the top. So if I go backwards a little bit more here, going up along the range, and if I said domain earlier, ignore me. We're talking about range here. The highest point it's reaching is this 3.33, the crest of the curve at the top here and the divot in the curve down there. So the range of this graph is 3.33 down to, where is it, about -1.17. All right, so to write this, go back to where I can actually write these things. Ooh, wrong one. This point, lowest value, let's choose a different color here, purple. The lowest value here had a y value of -1.17, and the highest point here has a y value of 3.33. So we would say the range here, and you always go small to large, is -1.17 all the way up to +3.33. And we really don't worry about these branches here left and right because they're accounted for on this portion of the graph. So whether they repeat y values is irrelevant as long as one of them exists. You don't have to worry about duplicates. All right, so that would be, oops, I forgot my bracket, the range of this graph. So the domain is from -3 to +2, and the range is from -1.17 all the way up to 3.33. last topic we can discuss about graphs is this idea of increasing and decreasing. So remember, as we're moving on these graphs, we're always going left to right. So we're always moving our domain in this direction. All right, so if we look at this, I'm talking about domain and range again. Now this one doesn't have any cutoff points, so the assumption is it goes on forever. So later I'll draw a little arrow down here and explain it. You can see this thing exists all the way to the left as far as I can go. And then as we move through the graph, as we move from left to right, this point A is going uphill. Now, it doesn't matter if it started in the negative region and ended up in the positive region. Here, the graph is going uphill until we get to that crest. Then it turns around and starts going downhill until we get to this divot. And when we get to the divot, it turns around and we start going uphill again. So it's really important to be able to look at this graph, and I kind of think of it as a stock price. You know, your stock price is going up, and then it's coming back down, and it's going back up again. So these create intervals of increasing and decreasing. All right. So I have this set up so that it colors green when it's increasing, and it colors red when it's decreasing. Let me get it back to starting point. Okay, and I'll turn the tracing on and run it through. So on this interval, and we always look at the x-axis, we do not look at the y-axis. Really, the only place you look at the y-axis is to answer range. All the other answers, increasing, decreasing, and domain, all literally come off the x-axis, the domain of the function. So these green lines are hitting the x-axis where this function is increasing. So it's increasing all the way to the left. I don't have it coloring that way, but it's all the way to the left, all the way up to this -2. All right, and then we're going to keep on going, and now it starts coloring red, so now the function is decreasing, going through the origin, and then ending up here down at 1. So this function is decreasing from -2 all the way up to this +1. All right, if we keep moving it, it starts increasing again, and it just keeps on doing that for, well, ever, as we drag it off to infinity. So, drag this all the way back. There we go. Get all that nice color in there. So this function is increasing and decreasing depending on whether it's going uphill or downhill. So let me get into the notation for it. Next page. So here's the picture basically. And when you're looking at this graph and it goes off the screen, the assumption is there's these arrows. And these arrows represent two things. They're going down forever, and in this case it's going to the left forever. And then there's this arrow over here that's going up forever, but it's also moving to the right forever. So we're talking about infinities here. So when I say what is the domain of this function, well, I look at this arrow here and it's going all the way to the left forever. So the domain of this function would be from -infinity to infinity. Just bringing everything together. All right, if we're talking about the range of this function, well, the graph goes down forever. There's no holes in what I'm looking at, the picture-wise, and at this arrow, it's going up forever. So the range on this thing is -infinity to infinity. Notice also I'm using these parentheses because you cannot contain infinity. All right, let's talk about increasing. So increasing, when is this function increasing? Well, whenever it's going uphill, these green intervals. So the green interval starts at, well, I didn't shade it all the way in, but it starts all the way to the left. So it's increasing from -infinity all the way up to, that's where it stops being green, and the x value it stops at is -2. Now, depending on your textbook, you can put a bracket here or a parentheses. It really doesn't matter. But generally, at that point, by itself, it's neither increasing nor decreasing, so most books will put a parentheses. not including it. But if you do include it, it doesn't really hurt anything. All right, the function is decreasing on the next part of the interval from here to here. So the x value it starts decreasing at is -2 all the way up to +1. So I'm going to say -2 to +1. This function is decreasing. And then at this point, it turns around and starts going back up for the rest of the trip. So we're going to say union. It starts back up, going back uphill at 1, and it'll keep going uphill off to positive infinity. So here we have the domain, the range, the intervals of increasing, the interval of decreasing. And that's it. It's not that hard.